Welcome to my channel, dear student. See, here is the problem of integration, that is 0 to infinity, that is sin x by x equal to pi by 2. Okay. This problem was given to the exam Calcutta University Honors, that is 1987. So the technique here of this solution, I'm using with arbitrary constant related integral, and then we apply the differentiate, and then we get the answer here. So the technique here, let us assume a function like that with related to the arbitrary constant, which called a parameter. So see, this is f of a. Okay, a is a parameter. Now using 0 to infinity and e to the power minus ax and sin x by x, okay, where a is called parameter. Okay, now differentiate this with respect to a to the integral. Okay, so that is equal to 0 to infinity. We got here, this is respect to a, so minus a e to the power minus ax. Okay, this is here x, respect to a is variable, so x is constant, so sin x by x and dx, and that is equal to minus 0 to infinity e to the power minus ax and sin x and dx. Okay, now I am evaluate this value with the help of indefinite integral. Let I'm assume that I is equal to, this is here e to the power minus ax, and this is sin x dx, and this is here u into v. Let us assume this is u into v, so this is e to the power x integrating sin x and dx. So if we differentiate, then we got here a into the power minus ax. Okay, integrating this, we got here cos x and dx. Okay, so minus e to the power minus ax and cos x minus a into e to the power minus ax cos x and dx. Okay, again I is equal to minus e to the power minus ax, and this is here cos x, sorry, a into, again apply the u into v method, e to the power minus ax. This is here integral cos x, we got here sin x. Okay, you differentiate this, then we got minus a e to the power minus ax, and the integration of cos x, and this is sin x and dx, and that is equal to, actually c, so this is here a, actually I, so therefore I is equal to minus, taking common, e to the power ax minus x, and that is equal to cos x plus a sin x. Okay, and minus minus plus, this is minus a square into I. Therefore I is equal to that is e to the power ax cos ax a sine and whole divided by a square plus 1 and then plus c. Okay, okay, plus c. Now I am using the limit here, so that is if 0 to actually infinity, we can't put the infinity here. Let us assume this is a L. Okay, this is e to the power minus ax and this is cos x plus a sine x whole divided by a square plus 1. Oh, sorry, this is minus a to the power ax sine x by x. Okay, this is, so this is the result of only plus, so multiply and then plus, we got here plus, so it is minus ax and cos x plus a sine x whole divided by a square plus, and this is 0 to L. When L tends to infinity, then 0 to e to the power minus ax sin x by x, and this is equal to, if we put L, and that is actually tends to infinity, so the weak large number, as here is a is parameter and a is more than 0, okay, more than equal to 0, so here is a is more, so if we put here infinity, so the whole thing is 0 here. After that, if we put 0 in place of x, okay, then this is 1, this is 1 actually, so 1 by a square plus 1. Okay, so this is the result of this, we got this, therefore the f dash value, so f dash is this, therefore the value of this is, okay, so you can say f dash a equal to this, so f dash a is equal to 1 by a square plus 1, therefore f of a is equal to minus integral dA by a square plus 1 plus c, and that is equal to f of a minus tan inverse a plus c. Okay, c, if we put 0 in place of 0, then we got 0 to infinity sin x by x, and this is your queries. So now if we put 0, and that is equal to minus tan inverse 0 plus c, therefore c is equal to f of 0, and that is equal to e to the power infinity, and this is sin x by x, c. Okay, again I repeat, if we put 0, then e to the power 0 is 1, so 0 to infinity sin x by x dx, and this is your queries. So f0 is your queries, this is f0. Now this is c actually, so you have to find the value of f0. If here when it tends to infinity, then f of infinity, that is equal to minus tan inverse, so infinity plus c, and that would be minus pi by 2 plus c. But here now f of infinity, and that would be 0 to infinity, so e to the power, so this is a big large number, so this is a sin x by x, So this value is actually 0. So 0 actually when a tends to infinity, then e to the power minus x tends to 0. So this is 0. Okay. So therefore we can write here 0 is equal to minus pi by 2 plus c. This is from a. So therefore from a. So c is equal to pi by 2 and c, this is here c, that is equal to 0. So c pi by 2 got pi by 2, that is f0, and that is equal to 0 to infinity and sin x by x and dx. So value of this integral is pi by 2 is your answer. Okay.